Okay, in this video I'm going to review ways of obtaining some descriptive statistics for variables that are scaled at different levels of measurement. Um, Hopefully by this time you've gone through and reviewed my other videos providing review of descriptive statistics for variables that are nominal, ordinal, interval, and ratio level in scale. If you have not done so, this might be a good time to go back and review that because I'm not going to spend a whole lot of time on the conceptual side of things with this video. I'm mainly going to focus on how you can obtain certain types of descriptive statistics. So I have right here an SPSS data file that's open, and basically I have 5 variables in this data file, and I have values for each of those variables for that are associated with 21 cases or 21 observations. It might be worthwhile just to assume that, let's say these are 21 people that responded to survey items concerning their sex, their political party identification, their year in school, number of people that live in their household, and support for aggressive policing. So basically those are our variables, and these are the responses of 21 individuals to those variables. So first of all, let's just kind of look at our variables a little bit more closely. Sex, I have set up in my data set as being a nominal variable, and I have values of 1 that are associated with being male, values of 2 assigned as value code for females. For political party identification is also a nominal variable, and I've assigned values of 1 for Democrats, 2 for Republican, 3 for Independents, and 4 for none of these. For years in school, our year in school, basically I'm treating as an ordinal variable, reflecting the relative amount of education a person has had. So I've got freshman, sophomore, junior, and senior being reflected by value codes of 1, 2, 3, and 4, respectively. Number of people in the household is designated as a scale variable. In SPSS, you can't assign it as interval or ratio. You can only assign a variable as a scale variable, which would comprise both of those other scalings. Support for aggressive policing also is set up as a scale variable. So basically, the scale designation is for interval and ratio level variables. So first of all, we're going to look at representing nominal data, and I'm going to look at sex first, and then political party identification. So to look at sex, to get some descriptives associated with it, we're going to go to Analyze, Descriptive Statistics, and go to Frequencies. So in this case, I'm going to be asking for um, um, frequency counts and get a sense of the relative frequencies associated with the values of 1 and 2, which 1s are males and 2s for female. So I'm going to move sex over to this variables box here, and under charts, I'm going to click on bar charts. Basically, you would not be using histograms with nominal data, or ordinal for that matter, but we can use bar charts, and you have a choice between, in terms of what index you want along the y-axis of your bar chart. You can ask for frequency counts or percentages. I'm going to start with frequencies here and click on continue. Under statistics, the only measure of central tendency that's appropriate with a nominal variable is the mode, so I'm just going to click on the mode right here, then click on continue, and then on OK. So you'll see, first of all, that up here, the n, this is actually the sample n in SPSS. Valid reflects the number of cases that have valid values on your variable, and we had 20 cases with values on them. We had 1 case was actually missing. If we go back to our raw data set here, there was 1 missing data point for person number 21. So that's why the missing's there. So the modal value is the value that occurs most frequently in the data set. And so we had males actually were occurring with the greatest frequency, females obviously not the greatest frequency. So So you'll notice that we had, in this little box here, we've got frequency counts. So we have 12 males, we had 8 females. Again, because the males were coded 1, that's the modal value that we see up here in our data set, the 1. So, and then, so obviously if you add the 12 and 8, you get 20. And so this is the 20 that were valid up here. We had one case that was missing, and so when you add that 20 and the one case that was missing, that's what gives us our 21, reflecting the total number of rows associated with our data set. So at any rate, just kind of keep in mind that basically the frequency distribution that we're most concerned with is this one right here. And so when we look at our bar chart right here, you can see we've got males, which were our 1s, females, which was our comprised of our 2s. So the frequency of 12 is the height of the bar is reflecting the 12 males, and over here the 8 females. So there's a visual depiction of our frequency distribution right here. You know, if we take the frequencies for each of these categories and divide by the sample size, we end up with relative frequencies. So basically, if we take F and divide by our total effective sample size, we end up with relative frequencies. And if you multiply that by 100%, you end up with these percentages right here. So basically, the percent of males out of our total effective sample size was 60%. So the relative frequency, again, would just be a proportion. If you multiply that by 100%, we would have 60% of our distribution are comprised of males, and then if we take the 8, divide by 20, and multiply 100%, you get 40% for females. So we can represent that as well in our data set. If we wanted to represent use our bar chart with these percentages from this column right here, all we would do is under charts, we would click on percentages, and so these are those percentages. So basically the 60% that we have right here, that's for males. The 40% is for the females. Note that first, this little column right here for percent, this is the percentage associated with each of these cases right here. So males, females, and missing. So basically, these are just computed by taking the frequency for males, for females, and for the missing, and dividing it by this number right here, which would incorporate any missing cases. So if you multiply that by 100%, you get these percentages. So you really don't want to focus on that. You mainly want to focus when you're interpreting your results on these right here. Also keep in mind that there are no cumulative percents in the context of a nominal data, so this doesn't really make sense to reference when you're dealing with a nominally scaled variable. Now let's take a look at political party identification. So again, with party identification, we had 1s for Democrat, 2 for Republican, 3 for Independents, and 4 for none of these. So I'm going to click on Analyze, Descriptives, Frequencies. I'm going to reset, and then so that moves sex over, resets all the specifications I had previously, and I'll click on Political Party. Under Statistics, again, with a nominal variable, I can ask for the mode, but there's not really much else I can ask for and have it make any sense. Under Charts, I can ask for bar charts. Again, I can ask for frequencies or percentages along the y-axis. I'm just going to go with frequencies here. So you'll notice in this case the total valid cases is 21, and that's because there was no missing data on that particular variable. So where it says missing, we have 0, which reflects no missing data. The modal category or modal value was still 1, and that's because we had assigned values of 1, 2, 3, and 4 down here for independents and none of these. And the 1s appeared most frequently in our data set relative to the other counts. So That's why the modal value was 1 for this particular data set. You'll also see that in terms of the relative frequencies times 100%, these are the percentage of the distribution that falls at each of these values of 1, 2, 3, and 4, or basically Democrat, Republican, Independent, none of these respectively. So you can see that 52.4% of our sample is comprised of Democrats, 23.8% comprised of Republicans, 14.3% comprised of Independents, and 9.5% comprised of none of these category. We'll see that because there's no missing data, the percentages you see in this column match the percentages that you see right here in this column. And those, again, this column makes no sense in the context of a nominal variable. You'll see with our bar graph that we have, this is reflecting the 11 frequency count. This is reflecting the 5 frequency count for Republicans. For the Independents, this is reflecting the 3 frequency count. And down here, this is the 2 frequency count for none of these. Another type of chart I can ask for is a pie chart. I click on that and click on continue and OK, and I get this pie chart right here. So you can see, we have proportionally most of this sample is comprised of Democrats. It's actually about 52.4%. For Republicans, we have the next largest group, which is at 23.8%. The Independents was the next largest group at 14.3%, and the none of these was 9.5% of the distribution. Okay, so next let's look at our ordinal variable. We're going to look at year in school, so reflecting years 1 through 4 generally, the freshmen, sophomores, juniors, and seniors. So we're going to click on Analyze, go to Descriptive Statistics, Frequencies. I'm going to reset and put year in school in as my variable. In terms of measures of central tendency, I can ask for both the median and mode. Both of those can provide some useful information, but generally with ordinal variables, the best measure of central tendency is the median. So we're going to click on Continue, and under Charts, because our data still are categorical, we're going to utilize a bar chart. Again, we can ask for frequencies or percentages along the y-axis. So I'm going to click on OK, and so now we see our number of cases that are valid are 21. We had no missing values. So we have 21 cases in our total effective sample size. So the modal value is 1. And basically, again, I just wasn't very creative when I created this data set right here. But basically, these were the value codes associated with these values on our variable. And freshmen had the highest frequency, followed by the sophomores, followed by juniors and seniors. And so you can see then that the modal category or modal value has to be the 1 that we see right here. The median of the distribution represents that portion of the distribution that divides it into equal halves. And so the median is actually 2. So, so that is our value for the median of this particular distribution. So you'll notice that we've got, looking at the bar chart, we've got freshmen, sophomores, juniors, and seniors. And basically you would interpret this pretty much the same way that we interpreted the bar charts or bar graphs above with respect to sex and political party identification. Once again, we had, in terms of the percentages, you can see there's the percent of freshmen, percent of sophomores, percent of juniors and seniors right here. Now, it does make a little bit more sense to look at the cumulative percentages. So these are basically reflecting ranks, if you will, or basically the percentage of the distribution associated with each of these ranks. So in our distribution, we had 42.9% of the distribution was comprised of freshmen. If we add in all the sophomores, then at 2 right here, we had 71.4% of the distribution were either freshmen or sophomores. With respect to juniors, we had 85.7% of the distribution that were freshmen, sophomores, or juniors. And then obviously 100% of the distribution is comprised of freshmen, sophomores, juniors, and seniors. So this is the percentage of the distribution with a given value on our variable and below in terms of their ranks. So now let's look at our variable support for aggressive policing. So this is going to be treated as an interval variable. Like I said, when we look at our scaling, it's going to be set to scale to reflect that. So now in this case, we are going to create some descriptives for our intervally scaled variable. So I'm going to go to Analyze Descriptive Statistics, go to Frequencies, hit Reset, and I'm going to ask for support for aggressive policing. Where it says Statistics, now I can ask for the mean, median, and mode. The mean oftentimes is probably is the best indicator of central tendency for interval and ratio level data. So, but I can also ask for the mean, median, and mode for the distribution as well. In terms of the indexing the variation in scores on that particular variable, I can ask for the range, variance, and standard deviation. And in terms of the skewness and kurtosis values to capture the amount of asymmetry and peakness in relation to tailness of the distribution, I can click on these two indices right here. And so now I'll click on Continue, and then on under Charts I can ask for histograms, and so then I'll click on Continue and then on OK, and so now you can see I get a lot of information here. So I've got, in this little box up here, I've got the number of valid cases. There were actually no missing data points. The mean of this distribution was 24.71, the median was 26, and the modal value was 30. So when we look at our frequency counts associated with each of our values in our distribution, there's the 30, and that had a frequency of 3, and there were no other values on our variable that had a frequency equal to or higher than that number. So that's why we have the modal value of 30. The variance was 85.414 and the standard deviation was 9.24. The range for the distribution is 38. It was just computed by taking 40 minus 2, and so that's what gets us the 38 that we saw here. If we look at our skewness statistic, you can see that this value is negative. So if you look at skew, a 0 would indicate lack of skew, a negative value would indicate a negative skew, and a positive value would indicate positive skew. And so basically we're looking for skewness values. The preferable range is between -1 and +1, and obviously values that are closer to 0 is better when we're trying to assess the normality or relative normality of our variable. So in this case right here, this is falling between -1 and +1, which would be fairly consistent with conventional cutoffs for our conventional. This would be fairly consistent with what we would expect with a normal distribution. In terms of kurtosis, our value was positive, so again, kind of using the same general logic, value of 0 would be consistent with a normality. A positive value would indicate leptokurtic distribution or positive kurtosis, a negative value indicating a platykurtic distribution or negative kurtosis. So we have a bit of a positive value here, which is indicating a little bit more of a leptokurtic distribution. So when we scroll down and we look at our histogram, you can see right here that we've got basically we have a bit of a negative skew. You can see kind of roughly that the data is sort of trailing off a little bit in this tail. So there's a negative skew that we see, um, and um, and again we appear to have a little bit of a positive kurtosis in the data. Um, you'll see that if we wanted a little bit more, if we want to plot our data against what would be expected with a normal curve, we can actually click on Show Normal Curve on Histogram. And so this plots out our data in relation to what would be expected with a normal curve. So you can see that our data is not fully matching up with what would be expected if our data were following a normal distribution. But it is falling somewhat in the ballpark, but it's not certainly not perfectly normal. We also want to keep in mind that in normality, there is no data set that will be perfectly normal in shape. So normality, or perfect normality, is an ideal, and we evaluate our data in relation to that ideal. So we're sort of looking for um, to see if our data is reasonably in the ballpark, or reasonably consistent with that normality ideal. So in terms of kind of visually, yeah, we've got a hint of a skew in our data. We have a little bit of positive kurtosis, but for the most part, it's fairly consistent with what we would expect if it was coming from a normal population distribution. So at any rate, we can look further at our chart here, or table here. So again, we have our frequency counts associated with each value that's observed in the data set. The valid percent is representing the percentage of the distribution with these different values, and so it's just basically computed by taking the frequency count for that value and dividing it by the total effective sample size. If there was missing data on let's say a couple of those um, cases in our data set, we would have a little line here down here below. It says missing, and it might have like 2 if there were missing values on those 2. So the valid percents would be reflecting taking the frequencies and dividing it by the total effective sample size, but the percentages in this column would be computed by dividing each of these frequencies by the total, which would incorporate any missing cases. So again, really when you're trying to interpret the percentage of the distribution where the certain values are observed, you really want to focus on interpreting this column. In the cumulative percent, these are the percentage of the distributions that fall at or below each of these values that you observe in the data set. Keep in mind too that again we have our mean, median, and mode that's computed right here. The median is the 50th percentile of the distribution. If we wanted to ask for other percentiles, we can certainly request that as well. If we go to Analyze, Frequencies and Statistics, we could ask for, say, the 25th percentile. And if we wanted to ask for that, we would just click on this little button here and type in 25, click on Add. If we wanted to ask for the, we'll just go ahead and ask for the 50th, even though we get it with the median. If I want to ask for the 75th, I can just type in 75 here. If I wanted to ask for the 87th, I could type that in here. So basically, when I click on Continue and on OK, you can see that the 25th percentile is 19. So basically, at a score of 19, we have 25% of the distribution falls at or below that score. Basically 50% of the distribution falls at or below the 26. 75% of the distribution falls at or below 30.5. 87% falls at or below 36.28. I have seen that in terms of computing these things, that these indices, the percentiles and the median, that that these are computed a little bit differently from some of the ways that other ways that you might see how these things are computed in textbooks and so forth. One suggestion that I ran across in one of the textbooks that I use in my classes, they recommend when clicking on statistics, ask for values or group midpoints. So using that when you're asking for percentiles in the median. And so when you're dealing with continuous data, clicking on that, and then when you click on continue and on OK, then these values are adjusted. So they're not exactly the same as what we had previously up above, but these are adjusted and they're calculated from group data. So just keep that in mind as an option when you're dealing with continuous data. Okay, so looking at number of people within the household, this is a ratio level variable. And so we'll just do the same thing. We'll just ask for the same general types of information. I'm just going to hit reset. Number of people, statistics, I'm going to ask for the mean, median, and mode, standard deviation, variance, range. I can ask for the percentiles. I ask for the 25th. Since the median is the 75th, I'm just going to go ahead and ask for the or 50th percentile. I'm going to ask for the 75th percentile. I can ask for skewness and kurtosis, and then in order to adjust the percentiles and the median, I'm going to click on values or group midpoints. So click on continue. Under charts, I'm going to ask for histograms and ask for the normal curve on the histogram, and click on continue and then on OK. And so this is what the data looks like. So in terms of we had 21 cases that were that had valid values on them, so there was no missing data. The mean for the distribution was 1.8095, or roughly 1.81. So the number of people living in a household on average was 1.81 people. The median for the distribution, which again is calculated from using group data here, is 1.625. The modal value was 1, and that's because we had the highest frequency count, or for the number of people in the household. We had frequency of 11 associated with one person. We had frequency 5 cases that had 2 people, 3 cases that had 3 people in the household, 2 cases that had 4. So the mode then would obviously have to be 1 in this particular case. The variance was 1.062. The standard deviation was 1.03. In terms of the skewness, it's 1.024. So, this is indicating, kind of going back and looking at our little scale here, that's a positive skew in the data, and a hair higher than what we would typically prefer if we're trying to decide if our data is following a normal distribution. So it's a little bit on the little bit higher in terms of positive skew. In terms of kurtosis, it's actually a small negative kurtosis. So we have a little bit more skew, but a little bit less kurtosis that we're worrying about here. The range is 3, and that's just computed by taking 4 minus 1, so that gets us to 3. And our percentiles, again, are basically captured basically based on grouped data. When we scroll down a little bit further, you can see we have our frequency distribution. So again, these are the frequency counts associated with these values on our variable. The valid percent is just computed by taking the frequencies, dividing by n, and multiplying by 100%. So these are the percentages you see. So 52.4% of the sample had a value of 1, meaning that there was 1 person in the household. 23.8% had a value of 2, meaning that we had 2 people in the household. 14.3% had 3 people in the household. 9.5% had 4 people in the household. Because there's no missing data, these 2 columns actually are the same. In terms of the cumulative percent, this is the percentage of cases that fall at or below these respective values over here. So when we look at our histogram, you can see that there's that positive skew right here. So you can see that the data are are piling up more in the lower tail of this distribution, and you have sort of a trailing off in the upper tail. And so that's where our positive skew is actually coming from. So that pretty much concludes this short introduction to looking at descriptive statistics in SPSS.